Okay, let's take you back quickly. Rules of exponents. Anything to the 0 power is what? 1, except what? Except 0. Watch this. 5 to the 0 power, 1. Negative 3 to the 0 power, 1. Negative 3 to the 0 power is what? What's that one equal to? Negative 1. Why? Only the 3 is raised to the 0, not the negative. If they want the whole thing, you put them in parentheses. That's a minus 1. You know, if you try 0 to 0, it should give me what? Math error. Domain error. Can't be done. So anything to the 0 power is 1 except 0. Rule number 2. When you're multiplying, if the base is the same, what do you do with the exponents? Add them. When you divide, what do you do with the exponents? Subtract them, the top minus the bottom. When you have power to power, what do? You multiply. And if you have negative powers, it becomes what? A fraction, 1 over a to the power of n. These are the properties of exponents. So a few examples here. What is 2 to the 3rd times 2 to the 5th? 2 to the 8th, good. What is 5 to the 10 over 5 to the 11? Oh, let's make it negative 11, even the bottom. 5 to what? 21. 10 minus a negative 11. Minus a minus will make it a plus. What is 4 to the negative 3 to the negative 2? 4 to the power, you multiply the exponent, that's plus 6. What is 3 to the negative 2? 1 over 3 squared, and 3 squared is what, 9? 1 over 9. These are the properties of exponents. Now, why are we interested in exponential functions? Well, exponential function have, if you graph them actually, have a unique shape. This is what exponential function looks like. Y equals a to the x. And if x is positive and you graph it, all exponential functions will have that look. This is 0, 1. This is if x is positive. That's called a growth problem. It passes through 0, 1, every one of them. 2 to the x, 3 to the x, 4 to the x, 5 to the x will have that look. The only difference, as the number gets bigger, it gets steeper. As the number gets smaller, it gets like kind of flatter graph, slower. It will have that shape. If x is a negative value, the graph will be backward. It will look like this. This is when x is negative. That type of a problem is called a growth problem. This type is called a decay problem. You probably heard growth problem, decay problem. Growth when something gets bigger. An example, your money. If you put money in the bank, not in the stock market, it could grow a lot faster on the stock, but it could also drop. But let's say you put them in the bank, and the bank says it will give you 3% interest. Your money will grow exponentially. Not by a lot, because 3%, guess what the power is? 0.03. Very small. That's a slow growth. So if you go, and by the way, the equation every bank uses, I think I mentioned that to a lot of my students who are here tonight. I said it's the initial amount, e to the power of RT. When you put money in the bank, that's what every bank uses.
I love that street program. Used it with my dad.
E to the RT. Here's the bad, let me just show you the bad news actually about this, or the good news, depends which side you're on. If you have, let's say, grandma died, we're going to kill grandma, she left you 10,000 bucks. You go to the bank and say, I'd like to deposit that money. 10,000 bucks. They take your money, there's your 10,000. Let's see what's going to happen. Let's say you're going to take that money for 3 years. The bank said, oh, well, you know what, Mr. Quinn, you've been a good customer with us, we're going to give you 4% interest because we like your service, we want to keep you here. So here we go. Let's see what Paul is going to have after how many years? 5 years, Paul? Okay, let's put them for 5 years. I'm going to save them for college tuition for your daughter there. Is it your daughter? Yep. So it's going to be the 10,000 e to the power, the interest rate 0.04 times 5%. Let's do the math. That's 10,000 e to the power of what? 0.2? 10,000 times e to the power of 0.2. So when you go take the money out in 5 years, you're going to have 12,000. Is it 1,000 we put in? I didn't put 10,000. I guess I put 1,000. Let's say 10,000. Yep. I put another zero here. 10,000. I put the wrong comma here. We killed grammar for 1,000. It's not worth it. Let's make it 10,000. So you're going to have what? $12,214 and how many cents? 03? The bank will take the money and he goes, Mr. Haddad, we notice you need some money. Let's give you a credit card. Go ahead. You can write yourself a check from the money. We'll give you up to 10,000. So they take that 10,000 that Paul just gave them and give them to me, but they charge me 17% on my credit card. So in 5 years, if I don't pay the money in 5 years, what do I owe the bank? I owe them, because 17%, 10,000 e to the power 0.17 times 5. You might be able to get 12% in some of these banks.
12%?
Or you might be, yep, for credit card. Still low. I'm sure they charge you more than that. So guess how much money they're going to take from me? 10,000 times e to the power of 0.85. I need to pay him $23,396.47 by taking Paul's money, giving it to me. I got to give him that much money. From that much, they give 12,000 to Paul, and the bank will keep 11,000 some change. They love it when you only pay the minimum payments. You're their best customer because they charge you 17%. Now, 10,000 is nothing. Imagine if you're borrowing it to 300,000, 400,000 over 30 years. Yep. So those are the growth problem. Decay problem is when something decreases, radioactive material. You know? I heard some good news today. The U.S. nuclear weapon, they're working on some chemicals. Half-life is only 12 years. The stuff we use in Hiroshima and Nagasaki, half-life was 50 years. For 50 years, you didn't see anything. Now you look at Hiroshima, they're building all the stuff, beautiful stuff, but now it's 12 years. In 12 years, half of the radioactive material exists there. We have some stuff that has actually half-life of 100 years. That means if we have a gallon of that waste still sitting there, 100 years from now will be half a gallon. Another 100 years will be what? A quarter of a gallon. Another 100 years, 1/8 of a gallon. Or quarter, yeah. And so forth. So it takes like 500, 600, 700 years for the stuff to disappear. Now we managed to make it 10 years. We can kill you quickly, but 10 years after that we'll rebuild, you know. That's a decay problem, like this. Why are we interested in that? Because these actually function, the exponential function, the logarithmic functions are the inverse of each other. So let's talk about the logarithmic functions. If you take your inverse function and take a growth problem like this one, x is positive, it looks like this. If you try to find the inverse of that graphically, the inverse of that will look something like this. This is the logarithmic function. Notice just by looking at that picture, these are the log functions. By looking at it, I know a few rules about the log. I know what my domain is. My domain for the log function what's the domain? X is what? Greater than 0. That means you can't take the log of a negative number or 0. That's rule number 1. Negative number or 0. If I pull my calculator out and I try some of them, I go, can you tell me what the log of negative 5? They're going to say error. Domain error. Can't. Can you tell me what the natural log? Natural log is another log, just base e. Can you tell me what the natural log of 0 is? Going to say domain error. You can't take the log of a negative number or 0. Looking at that picture also tells me when x is 1, the log of 1 is always going to be what from that picture? What's the y value for it? 0. Let's try it. What is the log of 1? 0. What's the natural log of 1? 0. The log of any base, doesn't matter what the base, the log of 1 to any base is always 0. So I'm going to put A or B for the base. Doesn't matter if I use base 10. The log, by the way, here, that's log base 10. When you see me hit the log button here, that's really log base 10. When you see me hit the natural log, that's log base E. For those people, if you didn't take tech math or pre-calc, E is what? 2.71828? Some funky number. Very helpful in science, finance, business, engineering, chemistry. So there's the first two rules of the log. Rule number 3. If you have an exponential function, y equals b to the power of x, You can change that to a logarithmic function. You can say x equals log y base b. Now, I know for people who I had for tech math, we spent a whole week on that. We cover that. If you took pre-calc, probably cover it. But for those people didn't cover it, let's say I came in and I said, you know what, I didn't even tell you what the log is, but can you tell me what is log? Solve this equation for me. 32 base 2, what is that equal to? I don't know. I didn't cover log. It's been a while. Well, if you use this rule here, it says you can take that and change it to what? 32 equals the base. What's my base here? 2 to the power of x. 2 to what power is 32? Anyone? 5. X will have to be 5. So by switching it to this, I managed to solve that. If I wanted to use my calculator, it doesn't really help me because I don't have log base 2 on this one. This has only log 10 and log e. Now some of you might have a programming calculator, you can put any base there. Mine doesn't. Another example while we at it. That's B, the base. I didn't give you the base. So notice I have to give you 2, find the third one. I can give you any 2 and ask you for the third one. So when you look at this, that's what? Change it using this property. It says, 81 should equal b to the power of 4. Here I was looking for the power. Here I'm looking for the base. What number, if I raise it to the 4th power, the answer is 81? Is it 3 to the 4th equals 81? So b will have to be 3 here. What else do we know about the properties of the log? There's 1, 2, 3, there's 6 of them, or 7 even. I call them 6 plus. The 4th one. If you have multiplication, log x times y, base b. What is that equal to? Remember, the log is like an exponential function. So what do you do when you multiply two exponential functions? What do you do with the exponents? You add them. So this one says when you have a multiplication, you can break it down to what? Addition. And what happens when you have divisions? What do you do with the exponents? You subtract. And the last one, I'll put them there. Power to power. What was the rule for power to power with exponential functions? Multiply. It says if you have power here, you can take the power to the front. Log x base b. I don't know why I use parentheses. I don't need the parentheses, but that's okay. So I can take my power and move it to the front if I want to. And these are the 6 properties of the log. Let me practice just quickly here with them. If I say Can you simplify this one? The natural log of 10 over 9. You can take this and rewrite that as what? The natural log of 10 minus what? The natural log of 9. If I said the natural log of square root of 3x plus 2, the square root means the power of what? 1/2. I can use rule number 6, which says take the power and do what with it? Move it to the front. And I can't break an addition or subtraction. I can't simplify this. That's addition. What's the log of 6x over 5? The log of 6x over 5 is what? That's a fraction, the log of 6x minus the log of 5, right? Are we done with that? Can I simplify that more? 6x means what? Isn't that 6 times x? So I can use rule number 4 to break it down. That'll be the log of 6 plus the log of x minus the log of 5. Why are we interested in log? We're almost done. Why are we interested in the log and the natural log? Well, this is actually one way to solve an exponential equation. A lot of times I come in and I say, you know what? I make a statement that says, if you can get 10% interest on your money will double every 7 years. And people say, how do you know that? Then I got to go through the math and prove it. So let's see. The statement I'm making, at 7% interest, your money will double every 7 years. Close to 7 years, actually 6.93. We use 7. And I'm going to prove that to you. So I'm going to go to the bank today, and I got with me $1. That's it. That's all I have. I'm going to go to the bank. I want to see which bank will give me 10 at 10%, not 7%. I'm going to see which bank will give me 10% interest. They're going to hold my dollar for now 7 years. Better give me some good return. So Bank of America somehow says, we'll give you 10% interest on that dollar there. So let's see how long will it take it to double. Double means when I go take my money out, they're going to give me what? $2. Here we go. Nice crispy. So the amount of money, it's the initial deposit, e to the RT. I'm going to have $2 if I deposit $1 at what interest rate? 10% times t. I need to solve for t. I want to see if it's really 7 years. So t equals what? E to the power of 0.10 t. How would I solve that equation now? That's why we're interested in the log. I need to get rid of that e there. Well, here's the good news. If you have e to the power, and you take the natural log of that, the natural log is what? look at your calculators, right over e to the x, or e to the x is over the natural log. What does that mean? They are the inverse of each other. And we say if you take the inverse of the function, what will happen? They cancel each other out. So you're going to end up with the power. The same thing. If you have 10 raised to a power, 10, not the natural, not e. In this case, you want to take what? The log. The log and 10 are the inverse of each other. You see them on the calculator there? They are the inverse of each other. They will cancel each other out, and the result is the power. So now I look at this, I have e here. So what I'm going to do, take the natural log of both sides. And so this will be the natural log of 2 equals, what will happen, the natural log of e? They cancel each other out. You end up with 0.10t. What is t equal to? The natural log of 2 over 0.10. Where's my calculator? The natural log of 2 divided by 0.10. Ready for the answer? 6.93 years. So when we say your money will double every 7 years, we are not kidding actually. At 10% interest, your money doubles almost every 7 years. Another one, then we're done. Solve this problem. Couple of problems actually we'll do, 2 problems. 7 equals e to the x plus 1. Solve it for x. What I'm going to do, since I have e to the power, I'm going to do what? The natural log of both sides. The natural log will cancel each other. Natural log of 7 equals what? X plus 1. To solve for x, what do? Take the plus 1 to this side, becomes a minus 1 plus the natural log of 7, whatever that number is. Minus 1 plus the natural log of 7. If they ask you for the exact answer, you leave it like this. If they say round the answer to 2 decimal places or 3 decimal places, that means go ahead and use your calculator. One more. The natural log of 2x minus 3 equals 5. Solve it for x. I have the natural log. How do you get rid of the natural log? E to the power. Remember, they are the inverse of each other. E in the natural log, cancel. You end up with what? 2x minus 3 equals what? E to the 5. Take the minus 3 there. 2x equals what? 3 plus e to the 5. And to solve for x, we're going to divide it by 2. Again, if they are asking for an exact answer, leave it like this. If they want to round it, then that will be 75.7. Exact answer, approximation.